example is that, like, if you talk about a circle, equation of a circle is x square plus y square is equal to a square. But it has a parametric form also, that is, you have studied in class 11th, that you can take x is equal to a cos theta and y is equal to a sin theta. Why we can take it like this? Because if we put x is equal to a cos theta, this will be a square cos square theta, and y as a sin theta, this will be a square sin square theta. And now when you add them, you will get a square common, and cos square theta plus sin square theta, and cos square theta plus sin square theta is 1, so you will get a square. So you are getting the right hand side. So here x is equal to a cos theta and y is equal to a sin theta is the parametric form. Now if you want to find dy by dx, what you will do, you will differentiate y with respect to theta, differentiate x with respect to theta if they are given in parametric form, and the derivative of y with respect to theta, as you can see here, that y is a sin theta. So if you differentiate it with respect to theta, a will come outside and derivative of sin theta will be cos theta. Similarly, you will differentiate x with respect to theta. So a will come outside and derivative of cos theta is minus sin theta. So in the next step, a cancels and you get minus cot theta. So this is, you get dy by dx. So this is called parametric differentiation, or differentiation of functions in parametric form. Now, first you can, if you want to note it down, you can note it down. Then we will see little complex equations in parametric form.
No, don't.
Okay. So let us come to exercise 5.6. In exercise 5.6, if we take a question, let us suppose we take question number 7. So here it is given that x is equal to sine cube t by root cos 2t. Sine cube t by root cos 2t. And y is cos cube t by root over cos 2t. Now you have to find dy by dx. So t is the parameter here. Parameter is which varies. So dy by dx, if you want to find, so our task is to find dy by dt and dx by dt and then divide it. So dy by dt, if you want to find out, we'll differentiate this y with respect to t. So quotient rule will be applicable here. So root over cos 2t in the denominator, so it will become cos 2t on squaring, then root over cos 2t here, and differentiation of cos cube t. So you will apply the chain rule. So this is 3 cos square t, and derivative of cos t is minus sin t. Then you take a minus sign and you put cos cube t as it is and differentiate root over cos 2t. So that will be 1 by 2 root over cos 2t into derivative of cos 2t will be minus sin 2t, and derivative of 2t will be 2. So you can cancel this 2 here, and what you get is, in the next step, you can take cos 2t root over as LCM. This one, this last one in here, this root over cos 2t as LCM, and it will multiply with the denominator cos 2t. So this will become cos 3 by 2 2t. So, and this cos 2t root over into cos 2t root over will be cos 2t, root will vanish. minus 3 into cos square t sin t and plus cos cube t sin 2t. So this will be what we are getting here. So you can write till here, then we will proceed further.
Can you scroll it up, sir?
Okay. So now in the next step, you can further simplify it. This is about trigonometry. So what you can take is sine cos square t can come out to be common, and you can say that this becomes sine 2t into cos t minus 3 cos 2t into sine t. So we can leave it till here, this dy by dt. This is cos 2t to the power 3 by 2. So this is dy by dt. Now we come to dx by dt. So you know what is x here? This is x. So would you like to differentiate this also and find dx by dt in the similar way?
No, yes.
Okay.
Oh, so how do you differentiate 1 by root of cos 2t?
That will be cos 2t to the power minus 1 by 2. So when you differentiate it, you will get minus 1 by 2 cos 2t. Okay. Oh, I did a mistake, I think. It will be minus 3 by 2, no?
Yeah.
Oh, I thought it is. No, no. So it is not minus 1 by 2, no? It is plus 1 by 2. Why it is minus 1 by 2? You are differentiating cos 2t under root, because when you apply the quotient rule, this will be v. This will be u. What you have to do is v square v du by dt minus u dv by dt. So why you will differentiate 1 by root over cos 2t? You will differentiate root over cos 2t. Getting it?
Yes. Oh, so it will be 3 sine square t cos t minus
One
2
one
sine
second.
cube.
1 second. 1 second. Let me sine cube t by root cos 2t. This is sine cube t by root cos 2t. Yeah, now you can tell.
3 sine square t cos t
3 sine square t cos t
minus 2 sine cube t sine 2t.
minus, sorry, minus,
2 sine cube t
okay,
into sine 2t
into sine 2t, okay, and
by cos 3 by 2 2t.
I think you might be missing something because when you will differentiate it, it will be cos 2t and then root over cos 2t into 3 sine square t cos t minus sine cube t, and the root over cos 2t will be 1 by 2 root over cos 2t, and in numerator it is minus 2 sine 2t. So this cancels, this becomes plus here, and then we have LCM, so cos 2t into 3 sine square t cos t plus sine cube t sine 2t by cos to the power 3 by 2t. So this should be 3 sine square t cos 2t is else required here, because after taking LCM there is a root over cos 2t and there is a root over cos 2t here. After taking LCM it will become a root cos 2t, and then minus minus it will become plus here, because minus of the quotient rule and the derivative of cos 2t is minus sine 2t. So it will plus, and then plus 2 sine cube t sine 2. That is fine. That is 2 is not there because 2 cancels. So this 2 will also be not there. Rest is fine. Are you getting it?
Yes, sir.
So this will be sine square t common, and we have 3 cos t cos 2t plus sine t sine 2t upon cos to the power 3 by 2 2t. So this is, yes, and there was yeah, and we have dy by dt. Now we have to find dy by dx. So if you want to find dy by dx, so cos to the power 3 by 2 2t is in dy by dt also and in dx by dt. That will cancel. And dy numerator is cos square t sine 2t cos t sine square t, sine square t, no, it is cos square t. So it is cos square t sine 2t cos t, cos square t sine 2t cos t minus 3 cos 2t sine t. And in the denominator, we have sine square t 3 cos t cos 2t plus sine t sine 2t. So this is the final answer. You can final result maybe in some another way expressed. Maybe it is cos squared by t by sine square t is cot square t, and maybe they have done something like divided by cos t cos 2t. So this will be tan 2t, and this will be minus 3 tan t, and this will be 3 plus tan t tan 2t. Maybe they have written like this because they have divided by cos t cos 2t and cos t cos 2t here in order to change them into tan only. So I think it may also be answer, or you can keep it like this also, not divide by cos t cos 2t. Leave it as it is.
And also,
Okay. So one question you can try is 8 and 11. These two questions you can try, question number 8 and question number 11. Then we can move on to the next exercise. Other questions are relatively easy. So that way you can do them as well.
it's exercise 5.6, right?
Yeah, 5.6. कुछ मम्मा ये तो बोलते मम्मा ये तो बोलते
Oh, so the 8 answers tan.
Sorry,
The 8 answers tan.
what are you saying? I'm not getting you.
The 8 answers tan.
Answer I don't have because I have just the PDF of that chapter. If you have NCRT with you, you can see the answer from that.
Oh, yes, it's 20.
Correct?
Yes, sir.
Okay.
So I'm not sure to do the 11th one.
11th one, you are not sure how would you be able to do it. So it is a to the power sine inverse t under root of that and a to the power cos inverse t under root of that. Okay, let us discuss it. So let us talk about dy by dt first. So it is root over a to the power cos inverse t. So if you see here, it would be a chain rule because there are three functions, one after the other, which are acting on it. The outermost function is square root. Then another function is a to the power and then cos inverse. So if you differentiate a square root, you get 1 by 2 a to the power cos inverse t to the power minus 1 by 2 because it will be n minus 1. Next, we will come to a to the power cos inverse t. So a to the power any variable is a to the power that variable into log of a that we discussed yesterday. E to the power x differentiation is e to the power x and a to the power x differentiation is a to the power x log a. Now we come to cos inverse t. When you differentiate cos inverse t, it is minus 1 by square root of 1 minus t square. So finally, what do we get is, we get here half a to the power cos inverse t. This is square root of a to the power cos inverse t in the denominator, log of a into minus 1 by root over 1 minus t square. So when we simplify, this will become log a by 2 into square root of a to the power cos inverse t into minus sign will be outside by root over 1 minus t square. So this is what we are going to get. Similarly, can you find dx by dt?
Yes, sir.
Okay.
So how did the root come on top for the root of a cos inverse t at the last step?
Okay, here
Yeah.
this is
How did the
power
root
1
come?
and this is power 1/2. So overall it is 1/2. This is a to the power cos inverse t by a to the power cos inverse t under root. So this will give you a to the power cos inverse t under root. Okay.
Yes.
What is dx by dt that you are getting?
So a root sine inverse t log a by 2 root 1 minus t square.
Log a root over a sine inverse t by 2 root over 1 minus t square. Right? This is dx by dt what you are getting.
Yes.
Fine. So we have almost done it. If you find dy by dx now, one second. When you find dy by dx, you will divide them. And what you will see that log a will get cancelled, 2 will get cancelled, and root over 1 minus t square will get cancelled on division. So this will be minus root over a to the power cos inverse t by root over a to the power sine inverse t. Now, what is root over a to the power cos inverse t? If you see, that was y. In the question, that was y. This is minus y, and this denominator was x. Therefore, dy by dx is equal to minus y by x.
Don't.
Okay. Second order derivative is the next exercise. What is a second order derivative? If you differentiate y with respect to x, you know how to do that. Now, after getting this, what you do, you differentiate dy by dx with respect to x. And this is called d2y by dx square. This is called second order derivative. For there is also a third order derivative, but we don't have to study that. But what will be that? That after getting dy by dx, you differentiate that with respect to x. And after getting that, you differentiate that with respect to x. So that will be d2y by dx cubed. That is third order derivative, but you don't have to do that. So if, for example, a simple example, y is equal to sine x, you differentiate it, you get dy by dx is equal to cos x. So what will be d2y by dx square? So you differentiate dy by dx. So cos x derivative will be minus sine x. So this is double derivative. Similarly, if you take a little different type of example, which is like sine of x square plus 2. So when you differentiate it, you know you will get cos x square plus 2, and further by chain rule 2x. This is what you will get. Now you are asked to find d2y by dx square. That means you will differentiate 2x cos x square by 2, which you got above, with respect to x again. So 2 will come outside and you will apply the product rule. So x will be there, and differentiation of cos x square by 2 will be minus sine x square plus 2, and x square plus 2 will be 2x. Then plus cos x square plus 2, and differentiation of x will be 1. Are you following this?
Yes.
But, sure?
Yes.
Okay. So final answer would be 2. Here the first term will give you 2 into 2, 4 x square, and a minus sign, sine x square plus 2 plus 2 cos x square plus 2. So this is the double derivative. So you can write this from here, second order derivative.
Also, business folder. Done, sir. Done, sir.
So there is an example 41 just before exercise 5.7. So let us do, you should first try it and we'll discuss. It says if y is equal to sine inverse of x, show that 1 minus x square d2y by dx square, that is the double derivative, minus x dy by dx is equal to 0.
So how do you do this?
We can first take dy by dx. So y is equal to sine inverse x is there. When you will take dy by dx, you will get 1 by root over 1 minus x square, right? Now do one thing, you can differentiate it again. So either you differentiate it again, or you first take root over 1 minus x square on the left side, multiply with this is equal to 1, and then differentiate it.
So why is it root of 1 minus x square?
Differentiation of sine inverse x.
Okay.
Differentiation of sine inverse is root over 1 by root over 1 minus x square. So you will then multiply it and you will write it like this. Now again differentiate. So when you will differentiate it again, so root over 1 minus x square into differentiation of dy by dx will be d2y by dx square plus dy by dx, and differentiation of root over 1 minus x square will be into 1 by 2 root over 1 minus x square, and the differentiation of 1 minus x square will be minus 2x, and the differentiation of 1 on the right side will be 0. Can we do this?
Yes.
So this 2 and this 2 cancels. Root over 1 minus x square d2y by dx square, this minus comes here, x by root over 1 minus x square dy by dx equal to 0. Now root over 1 minus x square, you can multiply as the LCM. This will become 1 minus x square d2y by dx square minus x dy by dx, and the root over 1 minus x square, which is in the denominator now, will multiply with 0 on the right hand side and will vanish from it. So this is what we have to prove: 1 minus x square d2y by dx square minus x dy by dx is equal to 0. Let us write it above.
Done, sir.
Okay. So from exercise, you can try Question number 11 you can try. And question number 14. You can try these two questions, question 11 and question 14. From exercise 5.7. So next exercise, which is mean value theorem, has been removed from your syllabus, right?
Yes, sir.
Okay. So today this chapter will get over. We'll start next chapter in the next class.
Okay. So I'm not sure how to do question 14.
Question 11, you got the correct answer. You verified.
Oh, yes, sir. Yes, sir.
Okay. Question number 14. Let me see. What is it? Yeah. Y is equal to A e to the power mx plus B e to the power nx. So y is equal to A e to the power mx plus B e to the power nx. And what you need to prove is show that d2y by dx square minus m plus n dy by dx plus mny is equal to 0. So let us find dy by dx. So if you find dy by dx, it will be derivative of this as we normally differentiate. So it will be a e to the power mx will be e to the power mx into m. That is mx derivative plus b e to the power nx will be e to the power nx into n, that is nx derivative by chain rule. Now you have to differentiate it again. So when you differentiate it again, what you will get? You will get a m square e to the power mx, because one more m will get multiplied, and b n square e to the power nx. Is it okay?
Yes, sir.
Now after getting d2y by dx square, let us put here. So left hand side will be equal to a m square e to the power mx plus b n square e to the power nx. Then minus m plus n dy by dx. So this is dy by dx am e to the power mx plus bn e to the power nx plus mn y. So mn and y will come from here, a e to the power mx plus b e to the power nx. So after writing this, let us expand them. Am square e to the power mx plus bn square e to the power nx. Middle term will get multiplied, both of them. Am square e to the power mx minus a m n e to the power mx minus b m n e to the power nx minus b n square e to the power nx plus a m n e to the power mx plus b m n e to the power nx. So finally we get this. Now what will get cancelled? Am square e to the power mx will get cancelled with minus am square e to the power mx. B n square e to the power nx will get cancelled, minus b n square e to the power nx minus a m n e to the power mx will cancel it, plus a m n e to the power mx and minus b m n e to the power nx will cancel, plus b m n e to the power x. So you will get 0, which you have to prove is equal to right hand side. You can note it down, write it down from here.
Done, sir.
Done?
Yes, sir.
Okay.
So in which formula is it like a m e m x is like you have to multiply the m and m?
How we differentiate it? That is what you are asking.
Oh, yes, sir. Like
So
which
e to the
formula
power
do we
x
use?
differentiation is e to the power x. So if you differentiate e to the power mx, it will be e to the power mx, and differentiation of mx will be m.
Okay, sir. Understood. Done, sir.
Okay. So let us, when we will be your next class?
Pretty sure it's tomorrow, sir, from 5
Tomorrow.
to 6 or 5 to 7 something.
Tomorrow? I
Oh,
doubt.
yes, I'm pretty sure.
Okay, because tomorrow generally we keep us off. So tomorrow is Friday. So there are normally no classes on Friday. So
Oh,
I'm not sure. That is, as a faculty, if I will be told, I will take the class. But that's normally what happens. So uh, let's see. Okay, if there will be class, I
yes,
will
sir.
take it. Okay,
Yes, sir. Okay.
thank you.
Bye, sir. Thank you, sir. Have a good day.